you doing?
Good.
Awesome. So we have our usual stuff, scissors and glue so that you can cut out your items. We've got the 3 cutouts from Monday's lecture, which we're going to be using today. And then you will have your cutouts for today, which will be these 4 little graphs. And I asked you to please save 1 corner of your scratch paper. Yes, sir. Huh? Yeah, it doesn't have to be very big. So the one that I'm displaying for you here is going to be way bigger than you are going to need. You will need a protractor and compass today, as we will be drawing straight lines and doing one small construction. I recommend a highlighter today so you can highlight some important bits of information. Your typical writing utensils, pen or pencil. And then I recommend blue and red for today. Okay, so you'll see all those colors come out. All right, let's flip in through our notebook, see what we have here. This was last week, translations. This was Monday.
What was last week?
Last week was translations. Yeah, they're already up online. So if you missed it or need to watch it again, it's there for you. This is what we did on Monday. And so we will be continuing today. I've already got mine prepped, so I'll give you a few moments to find the items. All right, that's what my morning looks like before I find my glasses. And there's what it looks like when I get my glasses on my face.
Where are we gonna get that one from?
This one was from day before yesterday. Let me go ahead and give you my extras from Monday. You're welcome.
From yesterday.
Yeah, this were from Monday. Okay, so most of you should have it in your little baggies from Monday. If you were not here on Monday, you'll need to go and get some extra copies, of which I have run out. I'm sorry. Up here with me. Yeah, you have yours. Yeah.
Is it in the same page or on the
If you have room on the same page, you'll need at least, like 7 lines. If you don't have enough room, start a new page.
That's the beginning.
This is the beginning for today. You don't need a new title or new objectives. These are the same as from Monday.
So what before that?
The stuff from Monday.
Do I have to leave space
Huh?
for do I have to leave space?
No. Yeah, you can just start off. This is the first thing.
So that's what y'all did on Monday?
No, I'll show you what we did on Monday. Start it here. I'll give you that later. Is the monitor on? Yeah? Now? Scroll. Thank you. All right, now that we have this in, we're going to do this reflection in the x-axis, which means this triangle is going to flip over this line right here. It's going to go whoop, like that. Okay? Now I want you to take a really close look at this algebraic notation for the reflection. What do you notice that's changing about those coordinates? Which one in particular?
Negative. Negative y.
The y gets a negative. Keep that in mind, okay? The y is going to get a negative. I need to name these vertices. Go. I heard F. I heard R, and I heard A. All right, what we're going to do is I want you to please list the coordinates for those points. Make sure that I listed the correct points, because I'm really bad about putting the wrong points. I've got one thumbs up that I put the right points. Another thumbs up I did the right points? Another one. Okay. Thank you. Another one confirming that I got the points right.
One.
All right, so let's look at these coordinates again, this algebraic notation. You said that the change was that we put a negative on the y coordinate, right? That's what you had mentioned right here? That was the change? To make that happen, you multiply the y coordinate by -1. And so that's the only change that we're going to do to coordinates to get the reflection in x, is we will multiply the y coordinate by a -1. Okay? So let's come over here where we see our coordinates, and we're going to multiply the y coordinate by -1. So here's my coordinate for r prime. Do we do anything to the x coordinate?
No.
So leave it alone. What do we do to the y coordinate?
Multiply.
All right, so 2 times -1 is,
-2.
and we have our new coordinate. Do that for every vertex that you have a coordinate for. And I'll scoot back over to the right in just a moment so that you can grab the information that's over here. Make sure I did my multiplications properly. Did I? Yeah? Now plot your image. Graph your image. Once you have the points graphed, take your protractor straight edge and connect the reflected points. Bless you. Bless you. Bless you. And there's our reflection. Questions? I'm going to zoom out a little bit so that you can see the whole page. And that way you can get this part over here in case you need it. Make sense? All right. Gonna go ahead and scoot down. Hold up, hurry. There it is. You got it? All right, get the next one set up. I left a lot of space. You don't have to leave a lot of space now. I was gonna do something, but I'm gonna sideline it for now. All right, let's look at this reflect in the y-axis. Those are the ones that you were looking for. Take a few moments to find those and get that into your notes. I'm going to label my axes really quickly. And this is plus, positive, negative, and negative. just so that I know which direction things are going. All right, look at the algebraic notation of this reflection. What do you notice? What do you notice? What do you notice? This is the original.
Oh, that's the negative.
Oh, the negative.
Yeah, the x changes. It gets a negative. So to make that happen, a reflection in the y-axis has,
By -1.
has you multiplying what by -1?
The x.
Yes.
Exactly, the x. So you're going to multiply the x by a -1. Let's name these vertices. Give me names when you're ready.
B.
I heard E. New voice from maybe somewhere toward the back.
L. S.
L, S. You know, S is a voice I haven't heard in a bit. All right, there we go. Go ahead and write out those coordinates for yourself. Start at one point and then work your way around in order.
Maybe they would have put the x after that.
So what was the change you needed to make
Oh, and then B.
in order to make this reflection? Look back over at the notes you took here to the left. What were you doing?
Multiply.
Multiplying what by -1? The x coordinate. So go ahead and do that right now for all of your coordinates. I'm going to leave the y coordinates alone. And then I'm going to change my x coordinates. Plot your image. Once you have them plotted, take your straight edge and connect to your reflected points. This will create your figure again. Do you have your pre-image and your image drawn? Hold up. I'm holding. Hurry, I'm slipping. I'm slipping. I can't hold on much longer. You're done. All right. Phew. That was stressful. If you still have room on your paper, please continue. If you are like me and you've run out to the bottom, go ahead and change your paper. You'll need at least as much room as you have already used for one of your examples. here's what the next one is going to look like. We're going to use the pentagon. And we're going to reflect in the line y equals x. Take a few moments now, make sure that you find the right graphics and you get them glued in at the right orientation. All right, so this isn't a reflection over an axis. This is a reflection over a line. In particular, this line right here, the y equals x line. I want you to notice the algebraic notation. What's changing? The y and the x, what are they doing?
Swap.
They're swapping, they're trading places. Swap x and y. Does that feel familiar? Where we had two things and we changed their positions? We exchanged them? Do you remember our crazy cousin that kept getting things in the wrong order? What was his name? Same name as a tennis shoe. Huh?
Mr. N something.
Converse. Yeah, and you flipped back to find it. Nicely done. So the reflection across the line y equals x is going to feel a lot like the converse from our conditional statements unit. Okay, where we're just exchanging the positions of things without actually changing the values. The first thing that we should do, put the phone please, is we're going to draw this line y equals x, right? Y equals x means that on this line, the value of y is always the same as the value of x. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. And so on and so forth. Do you see the little dashed line that we're starting to create by plotting these points? Take your protractor and draw that line. I'm going to draw the line really big so that we can see it. And I'm going to label this line y equals x. It doesn't matter where you label it. I just don't want to put it in my picture because I don't want it to get run over by what we're about to do. All right, I need to label the vertices. May I have the label for these vertices, please? Z,
J,
Q, A,
J,
J, L. All right. Like we did before, you want to grab the coordinates for the pre-image. Did I get the right coordinates?
Yes.
Yes? Okay, good. What were we required to do to the coordinates again to do this reflection?
Swap.
Swap them, which means everything that was an x is going to become a y, and everything that was a y is going to become an x. here's what that is going to look like. The y is going to become the x. And the x is going to become the new y. Make that exchange now for all points. As soon as you get those reflection points found, go ahead and graph them. Some of them are going to land on top of each other. Once you get them all plotted, and this one ends up really weird. This one ends up like way on top of itself. Connect the points. There you go. It looks like I just spun it, right? It's really, really weird to see, but this piece right here is now up here. You see it? So it looks almost like I spun this thing around in a circle. We're going to deal with rotations, the spinning thing, in probably in about a week or so. Next week, I think, we're going to start rotations. And we'll see if any of our rotations do the same sort of thing or not. Okay? All right, feeling okay with this one? All right. Let's do the last one. The last one is a challenge for you guys. Because on this one, you're being asked to reflect not across an axis, and not across a line y equals x, but you're being asked to reflect it across a line that has a non-1 slope. Slope is something else. And a non-zero intercept. And this one's weird. Okay? You like this one? Yeah. JK. All right, first thing we need to do is we need to graph this line. In graphing this line, there's some things to remember. This value is the y-intercept from Algebra 1. It's a -1, which means y-intercept is right there. This value is the slope. It's rise over run, which means from my intercept, I'm going to go up 1 to the right 4. Up 1 to the right, 1, 2, 3, 4. So there's my next point.
What?
Slope. Rise over run. From my intercept. So our slope is rise over run. From this point, I'm going to look at the numerator and I'm going to go up 1. And then I'm going to look at my denominator to the right 4. 1, 2, 3, 4.
Well, why are we gonna go up one?
Because that's what the slope says. Slope is always rise over run. Because our slope is 1 over 4, this means go up 1, and this
No,
means
like, what I'm trying to say is, like,
go right
why
fast.
did you start there?
I'm starting here because that's the y-intercept.
Oh,
You see it? Okay.
Whenever she grabs the line, it'll be crossing there at -1 on the y-axis.
And so it's a good starting point. Now that you have 2 lines, or 2 points on your line rather, take your protractor and draw that line. Because you only need 2 points to draw the line. I kind of went a little ham and I went off my page there. Okay. And I'm going to label this line, I'm going to label it over here because I don't want it to run into my reflection. So label your line. There's your line of reflection, y equals 1/4 x minus 1. And we have to reflect over this line. Now, unlike the other 3 we just did that had really very beautiful algebra rules, right? Just take the y and multiply by a negative, take the x and multiply, flip the 2. I don't have that same rule here. I don't have one. And honestly,
so are we done?
we're not. We're going to finish this one.
Oh, what's that?
And honestly, I don't know what the rule is. So from Monday, we have to construct the reflection. So from Monday, you're going to take your protractor. And you see right here this crosshairs? This line going this way is 90 degrees perpendicular to this edge of your protractor. You're going to line up this 90 degree with your line of reflection. Now sliding your protractor along the line of reflection, you're going to line up each vertex with the edge of your protractor. And we're going to draw lines that cross the line of reflection. I'm here below it, so I need to draw my guideline above it. Slide my protractor to the next vertex. I'm making sure to keep this lined up nice and straight. There's my vertex. And this is above the line of reflection, so I need this line to go down, below. Remember this from Monday? We're repeating it from Monday. And I know a few of you were not here on Monday, so this is what was going to be on, what will be on the lecture video. This one's below the line of reflection, so I need to draw it above. And this one is above the line of reflection, so I need to draw it below. Alright. Compass time. For each point that you are reflecting, you're going to use your compass to measure the distance between that vertex and your line of reflection, and you're going to copy that distance on the other side of the line of reflection. Recall that from yesterday? I mean Monday? Some of you were not here on Monday. So this is what's happening, what will happen on your video from Monday.
What happened?
Now, at some point, some of these are going to get too small for your compass. Like that one. It's too small. My compass doesn't close that far. So now we're going to break out that little corner paper. You remember I said save one of your corners? Put that corner right at that 90-degree angle between your line of reflection and the guideline that you marked. And you're going to use your pen and you're going to mark where that vertex is, right there. Then you're going to slide your paper up so that that mark is on the line of reflection. And then you're going to mark the edge of your paper. That is where that point belongs. Do it again with your other side, with the other side of your corner. Oops. I need to do it this way. I guess I have to flip my paper over. And once you have all 4 reflections, take your straight edge and mark them off.
Ma'am, I need attendance.
Okay, thank you. Oops, 21st. Thank you. Yep. Oh, Ivan. Yeah. Yeah, I think he was checked out. Sorry. There you go. Thank you. All right. Now this reflection is weird because we have to combine the whole, we're on a grid thing, and and the physical compass and protractor construction. Okay? All right. Thank you very much. Where's my mouse?
I think you hardly did it.